Copper, it's an ancient metal. Humans have used it for millennia. Think of early tools. Think of the Bronze Age. This element, number 29 on the periodic table, has shaped civilizations. It has quietly powered our progress. Its warm reddish hue is familiar. Yet its true importance often goes unnoticed. We live in a world built with copper. It is truly fundamental to our way of life. Look around you. Copper is hiding in plain sight. It's in the walls of your home. It carries electricity. It brings water through pipes. Your smartphone contains copper. Your television, your computer all rely on it. This humble metal is a superb conductor. We stand at a precipice of change. A green revolution is underway. We are trying to build a sustainable future. This noble goal has an unintended consequence. It requires vast amounts of copper. Electric vehicles, or EVs, are a perfect example. An EV uses much more copper than a traditional car, sometimes 3 to 4 times more. This is for batteries, motors, and wiring. Millions of EVs mean tons of new copper demand. Consider renewable energy sources next. Solar panels need copper. Wind turbines need even more copper. Each giant offshore wind turbine can contain many tons of this red metal. To harness the sun's energy and the wind's power, we need copper. Beyond the green revolution, our world continues to connect and build. Think of cities. They are growing larger. More people are moving to urban areas. Every new building needs copper. It needs it for electrical wiring. It needs it for plumbing systems. It needs it for heating and cooling. Skyscrapers reaching for the clouds are veined with copper. This urbanization trend shows no sign of slowing down. Then there's the digital world. We live in an age of information. Data centers are the new factories. They consume enormous amounts of power. They require extensive copper wiring. The Internet of Things connects billions of devices. So, where does all this copper come from? Copper is an essential element in our modern world, used in everything from electrical wiring to plumbing and even in renewable energy technologies. It comes from the Earth's crust. This crust is rich in various minerals, and copper is one of the most valuable among them. Copper ore is mined from deep underground or vast open pits. These mining operations are massive undertakings, requiring significant investment and advanced technology. But these resources are not infinite. Over time, the most accessible and high-quality copper deposits have been depleted. Like all minerals, copper deposits are finite. This means that as we continue to mine, the remaining deposits become harder to find and extract. We have been mining the easiest to reach, highest quality copper for centuries. Early miners could simply pick up high-grade copper ore from the surface. What remains is often harder to get. Modern mining operations must go deeper and further afield to find new sources of copper. This is a fundamental geological reality we must confront. Geologists and mining engineers work tirelessly to locate new deposits and assess their viability. A major challenge is declining ore grades. This means that the concentration of copper in the ore is decreasing. This means new mines often contain rock with less copper. As a result, more rock must be processed to extract the same amount of copper. Miners must extract and process much more ore. This increases the scale and complexity of mining operations. This is to get the same amount of copper. The process involves crushing and grinding the ore, then using various methods to separate the copper from the waste rock. Imagine sifting through more sand to find fewer grains of gold. This analogy highlights the increasing difficulty and effort required to obtain copper. This makes mining more expensive. The cost of equipment, labor, and energy all add up, making it a costly endeavor. It also requires more energy. Mining operations consume vast amounts of electricity and fuel, contributing to their overall environmental footprint, and it generates more waste rock. This waste must be managed and disposed of, adding to the environmental challenges associated with mining. To address these challenges, the mining industry is increasingly turning to sustainable practices and renewable energy sources. Innovations in technology and methods are helping to reduce the environmental impact and improve efficiency. The future of copper mining will depend on our ability to balance the demand for this vital resource with the need to protect our planet. By investing in research and development, we can find new ways to meet our copper needs sustainably. Section 5. Global Dance Geopolitics of a Red Metal. Copper supply is not just about geology, it is also about geography and politics. A few countries hold most of the world's known copper reserves. Chile and Peru are giants in copper production. This concentration creates vulnerabilities. Events in these key regions can impact the entire global market. It is a delicate balance of international reliance. Political factors can heavily influence supply. Governments might change mining laws, they might increase taxes or royalties. Sometimes political instability can disrupt mining operations. Resource nationalism is also a concern. This is when countries prioritize their own needs. Section 6. The Circular Dream. Copper Recycling's Potential. There is good news about copper. It is highly recyclable. Unlike many other materials, copper can be recycled without any loss in quality. This means that the copper we use today could have been mined centuries ago and still be just as effective in modern applications. Copper can be recycled over and over again. This continuous cycle of reuse helps to conserve natural resources and reduces the need for new mining operations, which can be both environmentally damaging and costly. It does not lose its valuable properties. Whether it's used in electrical wiring, plumbing, or even in renewable energy systems, recycled copper performs just as well as newly mined copper. Recycled copper is just as good as newly mined copper. This equivalence in quality makes it an ideal material for a variety of industries, from construction to electronics. This makes it a perfect candidate for a circular economy. In a circular economy, materials are kept in use for as long as possible, extracting maximum value before recovery and regeneration. In a circular economy, we reuse resources, we minimize waste. By recycling copper, we can significantly reduce the amount of waste that ends up in landfills and decrease the environmental impact of mining. This is a powerful tool in our quest for sustainability. Recycled copper is already being used in a variety of sustainable technologies, such as solar panels and wind turbines, which are crucial for our transition to renewable energy sources. Current copper recycling rates are significant. However, there is still much more that can be done to improve these rates and make copper recycling even more efficient. About a third of global copper use already comes from recycled sources. This is a promising start, but it also highlights the potential for growth in the recycling sector. This is a good start. With continued effort and innovation, we can increase the proportion of recycled copper in the global supply chain. But there is room for much improvement. We can do better. By investing in better recycling technologies and infrastructure, we can make copper recycling more efficient and widespread. We need to collect more end-of-life products. Many everyday items contain copper, and by ensuring these items are recycled, we can recover valuable materials that would otherwise go to waste. Think of old electronics, cables, and pipes. These items are often discarded without a second thought, but they contain copper that can be recycled and reused, contributing to a more sustainable future. Section 7. Beyond Copper. The Quest for Alternatives. If copper becomes too scarce or expensive, can we use something else? Scientists and engineers are exploring alternatives. Aluminum is one major contender. It is more abundant than copper. It is also lighter. Aluminum is already used in some electrical applications, for example in high-voltage power lines. But it has limitations. It is not as conductive as copper. Switching to alternatives is not always straightforward. Aluminum, for instance, requires larger wires. This is to carry the same amount of electricity as copper. This can be a problem in space-constrained applications. Think of electric motors or compact electronics. Other potential substitutes might include carbon nanotubes or graphene. Section 8. Spark of Genius. Innovation to bridge the gap. Innovation is not just about finding alternatives, it is also about using copper more wisely, and it's about getting it more efficiently. Advances in mining technology can help. New methods could allow us to extract copper from even lower-grade ores, or from previously inaccessible deposits. Technologies like bioleaching use bacteria to extract metals. These could reduce the environmental footprint of mining. Every bit of progress helps. We can also design products differently. Think about design for recycling. This means making products easier to take apart, so the copper inside can be recovered easily. We can also focus on material efficiency. This means using less copper to achieve the same function. Section 9. The Copper Crossroads, Charting Our Future. As we stand at the intersection of progress and sustainability, copper emerges as a pivotal element in our journey forward. We have seen copper's vital role in our daily lives, from the electrical grids that power our homes to the intricate components in our electronic devices. It underpins our modern world, forming the backbone of our infrastructure enabling high-speed transportation and supporting advanced manufacturing processes. It is essential for a greener future, playing a crucial role in renewable energy technologies like wind turbines and solar panels, as well as in the development of electric vehicles and eco-friendly buildings. Yet its supply is under growing pressure. The extraction of copper is becoming increasingly difficult, with declining ore grades and more challenging mining conditions. Soaring demand meets the hard realities of finite resources. As urbanization and industrialization continue to expand, the demand for copper skyrockets, putting immense strain on existing supplies. Declining ore grades and geopolitical complexities add to the challenge. The geopolitical landscape further complicates the situation, with key copper-producing regions often embroiled in tensions and conflicts. This is the copper conundrum we face as a global community in 2025. The need for a sustainable and reliable supply of copper has never been more critical. The situation is urgent, demanding our immediate attention and action. Governments, industries, and communities must come together to address this pressing issue. The path forward involves a multi-pronged approach. We must explore various strategies to ensure a sustainable future for copper. We must aggressively pursue recycling. By reprocessing existing copper, we can reduce the need for new mining and extend the life of our current resources. We must turn waste into a resource. Innovative waste management techniques can transform industrial waste into valuable copper materials, reducing environmental impact. We must explore and develop alternative materials. Research and development in alternative technologies can provide substitutes for copper, alleviating some of the demand pressures. We must innovate in how we mine and use copper. Advanced mining technologies and smart operations can increase efficiency and reduce the environmental footprint of copper extraction. Each of these avenues offers part of the solution. By combining recycling, waste management, alternative materials, and innovative mining practices, we can chart a sustainable future for copper and, by extension, our world.